everyone, we are Group 18 and our project is about Amazon Electronic Product Review Analysis. So first, let me simply illustrate our motivation. Reading itself isn't enough, but reading reviews are really exhausting, especially for the popular products on the Amazon website. They usually have thousands of reviews, which is impossible for people to read all of them. Hence, there is a need of a system to summarize all those reviews. For the customer, it would be easier and faster to extract information from thousands of reviews to know the positive and negative feature of this product. And also for the seller, it will also be possible to see what do people like and do not like about their products, and to understand customers' preference. So, we're building the system using the Amazon Electronics dataset, which is about 1.5 GB. It contains 60,000 products with over 1.5 million reviews. It has features like the product ID, review test, and the rating score. Here is a summarization of technologies we use in this project. The system is mainly programmed using the PySpark environment, and the user interface is built on the Jupyter Notebook connected to the PySpark. We also use the Hive to summarize the information from the reviews, and also use the Python to script the product information from the Amazon website. We met several challenges during this project. The first one is robot check. It limits the amount of the product information we can scrape from the Amazon website, so we have to constantly delay during scripting process, and we also have to use multiple machines with changing IP address. And also for the review test, it has unbalanced distribution of rating. For most of the product, it has 80% of the positive reviews. And also the review tests are quite short, and it has a lot of informal sentence, so we have to test several algorithms to select the best one. The third challenge we met is the binomial separation feature selection. This feature selection method is quite advanced in the recent paper, so it does not have the built-in function in the Python. We have to develop our own version. This method is quite different from the common feature selection method because it could select the feature with sentiment indication. Intuitively, if a feature occurs a lot in the positive reviews other than the negative reviews, it could be regarded as a positive feature. So also on the other hand, if a feature appears more often in the negative review, then it must talk about the negative part of this product. Here is a summarization of our algorithm. We'll explore each steps into the detail. For the text cleaning process, we use a lemmatization considering the readability of the features to the people, and it also could remove the redundant information from the review. Also, compare with the other common text dataset like news and books. Product reviews usually have shorter lengths and involve a lot of terms expressing the personal opinion and description of the products. And the sentence of the reviews are really informal. So, apart from removing the stop words, we also generate a blacklist, which is a set of words that appear in a high frequency but without any sentiment indication, like the words Amazon, wood, hence. The whitelist is opposite to the blacklist. Whenever we encounter the words in the whitelist, we keep the original format of those words. Those words in the whitelist are usually the metric to describe the feature of products, like the centimeter, kg, gigabyte, and also abbreviation of technology terms like the GPS, DVD, MP3. For the feature extraction, we consider three candidates. The first one is the most common one, the single word. The second one is the 2 grams, which are consecutively 2 words in the reviews. And the second one is a two-words combination, which is every combination of two words within the 4 consecutive words in a sentence. So here's a simple example of them. So first, we compare the time of those 3 methods. It is quite out of expectation that 2 grams consumes a lot of time compared with the two words combination. We figure out the reason is because we use the PySpark built-in function after we switch it to our own defined function. Those 3 methods did not differentiate in the time-consuming part. And for the dimensionality, the two words combination is much larger than the 2 grams and single word. So the term frequency matrix will be super sparse, and it also increases a lot of difficulty to select the features. For the feature selection, we also consider the part of speech tagging. For the 2 grams and 2 words combination, we would only consider those phrases tagged as below, which is usually the expression of the personal opinion. So first, we compare the binomial separation and chi-square. The steps of these 2 methods are very similar, so there is no difference in the time cost. And we also found that 50% of the chi-square features and binomial separation features are the same. So here is a graph simply illustrates the correlation of these 2 methods. But the problem is that the chi-square select feature without any sentiment indication. So next step, we compare the binomial separation with the chi-square feature selection plus the maximum entropy model. Maximum entropy model is a classifier that could be applied in the sentiment analysis. It takes the bag of words as the input and train with the review ratings. So in the end, it could give us the sentiment indications of all those features we put into the model. For the time consumption, since the second method also trains the model, there is no doubt that it will consume more time than the first one. The below table shows the percentage of the features from those 2 models could be really regarded as a product feature that describe the people's opinion about this product. We could see that binomial separation generally has a higher accuracy than the second one. So here is a summarization of our findings. First, we want to highlight that blacklists and whitelists are very important for the dataset with a special context. And also for the feature extraction, we choose the 2 grams, and we use a binomial separation to select the positive feature and negative feature for the products. In the end, we also want to emphasize the part of speech tagging is very important for the opinion mining. Enhancing the part of speech tagging accuracy will improve the performance of the opinion mining. Here is some basic statistical analysis of our dataset. We could see that generally the product score is among the 4 stars, so we only treat 4 stars and 5 stars review as a positive review. And we also generate graph to see how ratings change with the time of a specific product. So here is a simple example illustrate our result. This product is called Sandex Ultra with 4,915 reviews. We could see some positive features of these products like super fast, plenty space, easy use, good memory, and also some bad features like card unreadable, low sponge, completely die, card crash. Now let's move to the demos. So here is our IPython notebook. We first input the product ID. So here comes the result. It shows the name of the product. So this one is a 64 GB memory card. And it shows how the score changed with the time and also the number of reviews. This is generally some features selected by the chi-square. Those are the positive features, negative features, and also the topics from the positive reviews and topic from negative reviews. Thanks for your watching.